All right, so now we are going back up, and we are doing common derivatives table, which is the last thing in your part 7. And then now we'll see part 8. So no problem, Captain. Let's go to the common derivatives table. I hope everybody has understood the principle of chain rule. When you have something which is not an x, what do? You differentiate normally, like you differentiate the outside, then you multiply by the derivative of the inside. That's just like what it is. So let's do, and when you differentiate the outside, we're just saying you differentiate the normal thing. So now let's do the common derivatives table, because this is a table which is not small at all. So I'll need you to be at your best. It's very small TBH, but I just need you to be at your best for the last ones. So now let's put it. The common derivatives table, you say to me, what on earth is that? What are you calling? Remember, oh my goodness, we are so full of cheat codes and things that help us. Because we are practical, these things are things that we know are going to be questioned on. So yes, we have to really stick to the book. So common derivatives table, you say to me, what is this now you are talking? Because we don't just learn things unless we know that they're important for you. So if you were to differentiate, if we say, what is d dx? Please don't be confused by notation. What is d dx of 3x to the 9 minus 7x to the 4 plus 5? What is this? It just means the derivative, right? You differentiate this. What do you get? 9 times 3, 27. It's now x to the 8. What are you using? The power root. Drop the power, reduce it by 1. So that's how we dropped it. 9 times 3 became 27. Reduce it by 1. It becomes x to the 8. Minus, drop the power. 4 times 7 is 28. It now becomes x to the 3. Okay? It now becomes 28 x to the 3. Then what is the last one? Derivative of 5 is 0. So this is going to be your final solution. What did you use here? You used the power rule, okay? Which is drop the power, reduce it by 1. Now, what about if we say to you, what is the derivative of sinh x, sine hyperbolic x? What is this derivative? Do you know it? You say, oh no, I can't use the power rule for that one. Yes, you can't. So you say to me, how do you know it? You go in already knowing it. And where do you learn it? On the common derivatives table. So that is why the common derivatives table is important. It tells you the derivatives of these guys. Trig functions, exponential functions, hyperbolic trig functions, logarithmic functions. You must know them. So let's do it. So here you'll be having y, and here you have your y prime or your dy dx. So we can just say y and y prime, okay, which is the derivative. So y prime, we know that is the derivative of y. Never forget that. So here we have sine x. Here we have cos x. You should remember the order. Sine, cos, then tan x, then sec x, then cot x, which is 1 over 10, right? Then cosec x. This is going to be the order. Remember this order for trig functions. Please, sine, cos, tan, sec, cot, and cosec. Because this is holding the key to a lot of things. Now, you say, what is the derivative of sine? It is cos. Derivative of sine is cos. The derivative of cos is negative sine. The derivative of tan. Now, tan and sec are related. Tan gives you sec squared x. But sec can't give you tan squared because it's weaker. Tan is the stronger one. It will give you sec squared. Sec is weaker. So what will it give me? It will give me sec x tan x. Okay? Instead of giving you tan squared, it will give you sec x tan x. It's the weaker one. Cot and cosec are just the same as tan and sec. Only thing that changes is the sign, but everything else is the same. Cot is the stronger one, so it will give you cosec squared x. Then cosec is weaker, it can't give you cot squared, but it will give you cosec x, then cot x, right? But you must put the negatives like this, and that is your trig. This, if you know this table, you have done the first part of your common derivatives table. You can rewatch it, stop, rewatch, whatever. Okay? Derivative of sine, cos. Derivative of cos, negative sine. The derivative of tan is sec squared. Derivative of sec is not as powerful as tan, so it's going to be sec x tan x. It can't give you tan squared. Then the derivative of cot and cosec, they give you each other, but cot is the stronger one. It will give you cosec squared. And then cosec can't give you cot squared. It will give you cosec, then cot. But remember, these last two should be negative. Now, if you know this one, then you know the one for hyperbolic trig. Because for hyperbolic trig is the exact same table. The only thing that is going to change slightly, the signs. So let's start with black. Let's put black to do our division. So now let's do it. Now let's put purple to do the things. So it's going to be, we have now sine hyperbolic of x. So we will be just copying this very same thing. This common derivatives table, when you get in your exam, if there's space, write it down. You will not be penalized for doing that. You write it down for reference sake, so that when you get a question, you can always look back and confirm. So write this down. So remember, we are now at the second part. This is you writing. You're going to copy everything here, but you'll be now putting hyperbolic, this h for hyperbolic, okay? You'll be putting this h for hyperbolic. For cos, it's going to be cos hyperbolic x. For tan, it's going to be tan hyperbolic x. For sec, it's going to be sec hyperbolic x. For cot, it's going to be cot hyperbolic x. For cosec, it's going to be cosec hyperbolic of x. Then we go to this other side. Now, what did sine give me cos? So what is sinh going to give me cos? Okay, hyperbolic x. Don't put the signs yet. What about cos? It will give you sinh hyperbolic. You copied this guy, but ignore the sign for now. This gives you sec squared. So here you write again sec hyperbolic squared x. Then this gives you sec x tan x. So it's going to be sec hyperbolic of x. Then tan hyperbolic of x. Then cot gives us the cosec squared. So here it will give you cosec hyperbolic squared x. Then cosec hyperbolics, now it will give you cosec hyperbolic x. Then cot hyperbolic x, like that. Then now what you're just going to do is, remember, everything is going to be positive except the last three. The last three are going to be the ones that are negative. So the signs are slightly different from this one here. This for here is these last three. And if you have them, you can always refer. You no longer need to remember anything. You just come back to this table. Are we done? No. Let's put the part 2 of our table and then we are done. This part 2 is not going to be long. So we've done trig and hyperbolic trig. I'm doing it all at once because this is you as well in the exam. So I need you to know that you can do it. If I can do it, then you can, okay? I'm just doing it off head. So why can't you? Okay, so now let's put it. We are almost done. We are almost done, please. Sorry for that. Let's put it. We have y and we have y prime. I'm proud of you. You've worked so hard. So let's put it. Now what are we putting? Now we are doing for the exponential functions. We start with e to the x. What is the derivative of e to the x? It's just e to the x. Then now, what is the derivative of e to the f of x? It just means e to the something which is not an x. What do we now do? Derivative of e to the f of x. You bring it, remember we said you do it like you do for this. How did we do for this? It just comes back. So it's going to just come back, e to the f of x. Then what do you then do? Multiply by the derivative of the inside. So you now multiply by f dash x. Remember, we said you do it just like you do for x. But remember, you should remember that this is no longer an x, it's an f of x. Then you multiply by the derivative of the inside. You're done. Then now we have the derivative of ln x. What's the derivative of ln x? It's 1 over x. Then now we have the derivative of ln f of x, which is something else which is not an x. Now for this one, just remember that the derivative of ln, anything else which is not an x, you close the ln, you look at the x. What is it? It's just an f of x. So for you to do, you are going to differentiate that f, then you divide it by itself, okay? It's like you ignore the ln goes out of the picture, okay? If it's ln, anything which is not an x, ignore the ln, look at this guy, the inside, which is not an x. Differentiate him, then divide him by himself, okay? Divide the derivative by itself. Then you have it like this. Oh, goodness, we are doing very well. Now we want, what is the derivative of now a to the x? We now want a to the x, not e to the x. A to the x, where a is a number, like 5 to the x. What is it? It's just going to be a to the x, ln a, okay? ln is for the number, not for the x. So it's going to be, it comes back as it is, but it multiplies ln of the number. So if it's 5 to the x, it's going to be 5 to the x ln 5, okay? What about if it's a to the f of x? Now you all know what to do. What do? You bring it as it is. You do what you would have done for here. For here, what would you have done? We would have just said, come with it, a to the f of x, then multiply by ln a, which is ln of the number quarters. So this will be 5 to the something which is not an x, 2x plus 3 or whatever. Then when you're done, you then multiply by the derivative of this thing which is not an x. So remember, at the end, you always multiply by the derivative of that guy. That is how you do. Then now we have the very last one. Wow. You have worked so hard, and that is log base a of x. How do you do it? This is just going to be like log base 2 of x. This is going to be 1 over x ln a. Oh, the way you like ln a. Ln of the number, yes. Then the x will just come in front. So it's 1 over x ln a. What about if it's log base A of f of x. What does this now become? It becomes 1 over f of x ln A. Okay, we do it like we would do for x. Then we must multiply by the derivative, which is f dash x. And then now it would be done. We do it like we would do here, but where there's x is now an f of x. Is now the guy which is there. And then you then multiply by the derivative of this. And you're going to be done. And this is your whole common derivatives table. You must remember it by heart. You get in the exam, you deposit it, you put it, and then we say, well done to you, bravo, we're so proud of you. That's how you must do it. Remember the common derivatives table. It has the key to all the derivatives, all of them. You can do them. If this table is in you, then you can kill all of them. You can get rid of them in no time. One more thing, ladies and gentlemen, and that is just now going to be the application, and we are done for our test 2, and we say, hooray, we've worked so hard.